All right, we'll get started because the community talks are a little bit shorter. So I've got about a minute for every slide, and I gotta get through them quickly. However, to start, I'd like everyone to be just really, really excited so that I can take a selfie of an audience that's like just extremely excited to watch this talk. Okay? So maybe on 3, everyone could just like, I don't know, just be real excited, okay? 1, 2, 3. Thank you. All right. Okay. So if you've come here to learn about synchronizing resources between distributed FHIR servers, you're in the right place. Very briefly, I'm Josh. I'm the CTO in FLEXPA, at FLEXPA rather. Occasional participant in some IGs. The Karen Digital Insurance Card is the one that I'm a co-author on. Goal for DevDays for me is just to meet more people working on patient access, payer-to-payer data exchange, really anything with claims data. Let's talk if you're one of those people. Okay. So let's start with the problem. We want to build a patient application that connects to any patient access API on a FHIR server out there in the wild, and that can discover all of the resources that are actually available on that server. And furthermore, copies those resources on behalf of a patient. So this sounds like a really simple problem. The great ChatGPT rendering of the problem with, I don't know, these are barrels of FHIR data or something, or in some cases, FHI. This is a problem that FLEXPA, the company that I co-founded, has attempted to do. So in production today, we connect to 416 payer patient access APIs. This is a requirement here in the US, and basically it's a patient access API that a health insurance company has to produce. So we connect to all of them, so hundreds of FHIR servers, and we have run into some problems. I'm going to narrow the problem, though. I'm not going to talk about keeping resources up to date. So this is a one-time sync problem. I'm not going to talk about copying all possible resources, just resources that the patient might be interested in. Not necessarily patient compartmentalized resources, but resources that at least are referenced by patient data. We're not going to talk about provenance, interesting problem. We're really going to talk about 3 core issues. We're going to talk about finding patient resources, extracting patient resources, tagging them loosely, and then storing them or loading them. But really, we're actually going to talk about that first problem the most. And I'm going to introduce 9 problems to you. So if you connect to a FHIR API on behalf of a patient and want to get all of the patient's data, there seems to be a pretty straightforward solution. It's the patient everything operation. It's really nice. One request, we get back patient data. We ran into some problems with this. First of all, in the network that we're creating, fewer than a third of the payers actually support this operation. It was never considered in the IG development for payer patient access APIs here in the States. So that's one problem. And that's going to be a recurring problem throughout this talk, is support of a possible solution. This is interesting. Speed is a problem. You would think that this would be faster than individual requests, but it's not always. Some everything operation implementations are actually slower than making individual requests. So the general advice to this is trust that this is a good idea, but verify that it really is. This is an annoying one. The everything operation technically can be paginated. So the spec has some interesting language about this. And what's confusing is that not all implementations actually paginate. So they have an upper limit of resources that will actually be returned. And pagination is sort of just forgotten on this operation. And then we come to compartmentalization. So this is actually a problem because, yes, if I'm acting on behalf of a patient, certainly We're interested in encounter resources, observation resources, anything that is compartmentalized, so to speak, within the patient. But that's actually not the only data that we're interested in. We're interested in resources that are also referenced that are not patient compartmentalized. So an encounter that took place at a given facility might be referenced in an organization. And we're interested in the organization too. The organization will not be returned to us. And we'll come back to that as a problem. Okay, well, maybe we can use batch transaction. So this is interesting. Before I started looking at this problem, I didn't realize you could do this, but you can do a batch transaction with read and search operations. Again, this is actually uncommonly supported by the Patient Access APIs. We simply stopped trying to do this. And again, this is a theme of many potential solutions and nerd-sniped ideas for me. Okay, so obviously our fallback has to be something like doing individual search operations. Great, we're rolling, except that capability statements don't always tell the truth, both in terms of over and under advertisement. So under advertising the resources that are actually supported, under advertising the operations that are supported. So under advertising support for everything, as an example. They don't always fully disclose the search parameters. Here's an annoying one. They also don't, there is no way in a capability statement for the server to advertise the maximum count available. So if you want to use the search result parameter underscore count, there's no advertisement for that. But fortunately, we've made a suggestion to build support for that was recently accepted. Then once you get down into this, there's also just weird connectivity requirements in actually sending the FHIR requests. Some implementations require extra headers. Basically, there's a world of non-spec problems that you'll run into when you connect to 400 of these things. And then we get into race conditions. So this will make more sense on the next slide, but you really have to be careful about the order in which you're doing these operations. And the reason for that is once you have returned a page of search operations, you need to process those resources and resolve all of the references that exist inside of them. So in that example of an encounter that references an organization, we need to go and actually resolve that organization and do a read operation. So this is pretty straightforward graph traversal. So we're going to walk the nodes of all of the resources, find the references, make read operations. But we also need to keep track of which read operations for which resources we have made. And if we're doing searches, individual searches, those searches may actually be returning to us the resources that we're attempting to resolve. So for example, encounter and provider or something like this. So a bunch of problems with reference resolution. Certainly rate limits is one. There's recursion depth. So how many times are we going to recurse this? And the duplication of effort or race conditions I just mentioned. And again, why not just use include? As a nerd snipe here, again, there's no guarantee of support at all. And you'll probably be back to this problem soon enough. So dealing with rate limits, well, certainly if you're making hundreds of potential requests to a FHIR server, you're going to run into problems. You will need to implement HTTP connection pooling at some point. Problems here. So 429 is an HTTP status code that basically says retry later. That's not part of the FHIR spec. It's very rarely supported. It's supported generally at the load balancer level of whatever implementation in the cloud the implementer has used. So those errors are generally not coming back as operation outcomes. Also, don't go too slowly, because if you go too slowly, your authorization could expire. So this was where I think we get into some even more interesting problems. So that we've really done the work of discovering and finding the resources. Now we need to process them and store them. And we have a really, really basic problem, which is that there's, in FHIR, logical identifiers are just strings, right? There's no guarantee that they're unique. So if you're connecting to 400 different endpoints, you could and should expect collisions. So there's a clever solution to this, which is that you can rewrite the IDs using UUID v5, which creates a hash over a namespace. So this is kind of cool because if you input the same patient ID, for example, if you have a patient resource that has a logical identifier of 123, I can consistently create a hash that outputs a UUID given a namespace. So this example here of assigning an ID to each endpoint and then passing in an endpoint and a patient ID means that for each endpoint, I can create a consistently unique patient ID that is also reproducible if I encounter that resource again in the future. Okay, but that creates broken references. So if I'm rewriting identifiers, logical identifiers, every reference to the old logical identifier that I've processed will be broken. Okay, so we need to fix all of the references and all of the resources. This is not such a hard problem. We can keep a map where the key is the old identifier, and that maps to our new UUID v5. So this problem is more annoying than it is difficult to solve. Problem number 8, resource validation. So of course, if you are connecting to hundreds of FHIR servers, the general advice on validation is just good luck. You probably need to adjust your expectations. John Postel is sort of one of the grandfathers of the internet, I suppose. Postel's law is that you should be liberal in what you accept and conservative in what you send. And so I think that's good advice here. You can fix what you can with validate before storage. Obviously, if you really do need to validate against a profile for some use case, you're not going to just be able to call validate. You're probably going to rewrite some data. Problem number 9 is now that we're ready, we've transformed, we've changed logical identifiers, we've solved the problem of extracting data. Okay, we may have 1,000 resources. We may have 10,000 resources. We may have 20 or 30,000 resources in patients with particularly long health histories. And this is actually not so unreasonable if you think about an insurance company supporting potentially the last 8 years of a patient's claim history. This actually becomes quite real. And 8 years is because of the mandate here in the U.S. 2016 is the mandate for data availability as a start date. So the general advice here is, well, definitely use batch transaction and use update as create. So this is a fun trick in FHIR. Not every server supports it, but you should probably use one that does if you're doing this, which is that when you send this bundle, this transaction, you can actually say that these are actually updates. So this here we see request method put and a URL. I don't know at this point if this resource actually exists in my FHIR server. I have no idea. And the work that it would take to figure out if I've already stored this or a version of this would be very costly at the number of resources I'm actually processing here. So use update as create. If it doesn't exist, it'll create it. So good implementations will allow you to do this. Problems, performance is really bad in basically every FHIR server if you're doing this number of writes. Bulk data import, question mark. That would be nice. It is technically in a draft state. So coming up on the last little bit here, and I'll take some questions. Generally speaking, solutions to this problem are, can't we just use X? Well, yes, but X is very rarely always supported, and you just have to layer solutions. You have to go down to the lowest common denominator as a fallback when you're connecting to hundreds of FHIR endpoints. One sort of lesson learned is that if you're working on an implementation guide that's going to be used at a national scale or used by hundreds of separate implementers, definitely consider conformance testing. This was not considered for CMS 9115. Well, I shouldn't say it wasn't considered. There wasn't the same conformance testing that was available for other patient access APIs for CMS 9115, and that led to just so much variance in the world. This is just not going to happen, but I think UUIDs for logical identifiers in FHIR would have been nice, but I think that's more of a mistake that probably can't be fixed. So yeah, Q&A. We've also released a report on the network that we built that I'll put on my Twitter there, but happy to take questions. Going up here.
So all of the issues that you mentioned.
There's a mic coming there, yeah.
Oh, thank you. All of the issues you mentioned seem to be from the perspective of a tool that does the aggregation of the data for a patient. Is that a fair understanding?
Sure. You could be a patient health record app or an aggregator or anyone who's attempting to get this data on behalf of a patient.
So I'm curious, from a payer perspective, what's your experience, the data exchange between payer to payer? Because most of the payers, they don't go beyond what the, as Virginia put it, regulatory guards, whatever they say. Beyond that, generally they don't.
That's true. So in our payer report, we give a grade for every payer. So if you happen to work at a payer, you can look up the score we've assigned you. But the best implementations actually did not just follow the letter of the mandate and actually expanded access. So Elevance is a really good example of this. Elevance went way beyond what they had to do in making patient data available, well in excess of the requirements of in terms of eligibility. As far as payer-to-payer data exchange, we're really optimistic about payer-to-payer and CMS 0057 and what's happening with the Da Vinci implementation guides. We're optimistic basically for two reasons. One is that the consent model is simpler. So the consent model requires a simple consent, meaning we don't have to do a smart-on FHIR flow if we're two payers doing the exchange. And I think that will lead to better exchange of data. I think the thing we should look for towards 2027 when that comes into production is conformance testing. I think conformance testing will be really important to reduce variance between payers.
You mentioned about the ratings that you guys have given to the payers. Is that something published on?
Yeah. I can send. If you go to my my Twitter, I'll put it up there. I'll post it in the comments for this talk.
Hey Josh, thanks for the talk. Very insightful to see what kind of real-world experiences you have running this at scale. Can you talk a bit about more of the problems you had with _include?
There's basically two problems, and this is like a repetitive problem, is support across all resources. In general, include is, even if you look at the spec, it mentions that most of the time servers will only support use of include on indexed references. So if you're if your objective is maximal extraction, then very frequently the references that are available through include, if it's available at all, won't actually support all of the possible fields. So you'll still end up back at doing individual reads.
Time for one more question.
Great.
Yeah.
Hey, Josh. So is it the same issue with FHIR bulk, that its adoption's the problem, and you just kind of have to fall back to something?
Correct. The IG doesn't mention the patient everything operation. It also doesn't mention bulk export. When the IG was released and when the mandate was released and when it came into effect in July of 2021, bulk was still more nascent. I think STU2 had just been published at that point. But certainly if we're building patient access API IGs today or issuing new releases, bulk export should definitely be supported. Great.
Well, thank you, Joshua, for your presentation.